Hello, pre-algebra students. Today we are going to talk about division, and this is again nothing world-shattering. It's stuff you already know, so we know at this point you're just doing a lot of practice, but I wanted to give you a couple of examples here real quickly just to give you a quick refresher on some things that you'll be doing. So first of all, division. Now you may be asking yourself, well, if you're going to talk about division, why do your problems all have fractions in them? And so that's the first thing I want to show us, that this fraction bar, and it's a fraction bar right there, that fraction bar actually means divide by. And so this actually means 108 divided by 9. So there's more than one way to show division, and one of the most popular, most frequent ways to show division in algebra is with the fraction bar. So that's something we need to get used to. But you know that the kind of the traditional way, the grade school way of doing long division is to set it up this way. 9 into this long division symbol there, 108. And this is what you will be doing. We'll do our work as long division for now. And we're just going to practice, making sure we've got all of our addition, subtraction, multiplication, division facts down, and then we'll move into easier or quicker ways to do this. Okay, so we say, how many times does 9 go into 1? And the answer is no times, so we could put a 0 there if we wanted to, but we don't have to. And then we say, how many times does 9 go into 10? And we say, well, 1 time. So 1 times 9 is 9. So we put a 9 underneath the 10, and then we subtract. 10 minus 9 is 1. So of course 9 doesn't go into 1, so we bring down the 8 for the next place value. How many times does 9 go into 18? And I hope you know the answer is 2. And then we say 2 times 9 is 18, so 18 goes down there, and we're going to subtract, and we get 0. And we love it when we have a 0 as the last thing down here. That means the remainder is 0, so we can say that 108 divided by 9 is equal to this answer right up here. That 0 in the front didn't need to be there. It's just 12. No leftovers. Now, let me show you this. We can check our answer because if 108 divided by 9 is 12, then 12 times 9 should equal 108 if we did everything right. So let's try it. 12 times 9. 9 times 2 is 18. Carry the 1. 9 times 1 is 9, plus 1 is 10. 108. Bingo. We got it. So the answer is 12. That was 108 divided by 9. We could have asked that question 3 different ways. 108 over 9, 108 divided by 9, or 108 divided by 9 in this configuration. All mean the same thing, and the answer is 12, no matter which way you ask the question. But of course, the long division method is probably the best. Okay, now, that's great, but let's do one more. Not because I think you need to see more easy problems, but maybe because this one is slightly more difficult. So 1,240 divided by 3, that's the same thing as 1,240 divided by 3, which is the same as 3 into 1,240. Okay, so 3 goes into 1 0 times. We can just put a dash there if we want to. 3 goes into 12 4 times. That dash is going to be confusing. It's going to look like a minus sign, so I better not do that. I'll just leave it blank. Okay, 3 goes into 12 4 times. 4 times 3 is 12. That was easy. We'll subtract. 12 minus 12 is 0. 0, 3 goes into 0 0 times. So we need some more numbers for 3 to go into. So we bring down, we borrow the 4. And 3 goes into 4 1 time. 1 above the 4. 1 times 3 is 3. subtract that from 4, we get 1. And now we borrow again, because 3 does not go into 1. And I like to check that because, if I did something wrong and I subtracted and I ended up with a number that could still be divided by, like 3, then I know that I just didn't do enough the first time. So I need to go back and, raise my number there. Okay, so I'm going to bring down the 0. Let me show you what I mean by that. Let me just do this wrong. Okay, so let's just say 3 goes into 10 2 times. Okay, 2 times 3 is 6, and subtract 6 from 10, and that's 4. And so then I check, okay, 3 goes into 4. Oh, it still goes into 4, so I must have not put enough 3's into the 10 there. It's actually more than 2 3's go into 10. So do you see what I mean? So I can kind of check my work by just taking the extra step of asking myself the question, does 3 go into the remainder, what's left over? Okay, so let's do it right this time. 3 goes into 10 3 times. I hope you know 3 times 3 is 9. And 10 minus 9 is 1. Uh-oh, there's nothing more to bring down. There's a decimal point here. You know that we could, if we wanted to work in decimals, we could keep adding zeros after the decimal, and we could keep on going. I know you've done that before. We're going to get to that. I know. We're going kind of slow here. But stick with me. We're going to stop there. We're not even going to do that. We're going to just say, okay, there is a remainder of 1, so we'll write that down. How can we write that? Well, we could just say R1, remainder of 1. Okay, now, so what do we do with this? That's kind of awkward. We are not going to turn this into a fraction yet. So we're just going to observe that there is a remainder. It does not go in evenly. So we're going to say that 1,240 divided by 3 equals, let's see, what was that? 413 remainder 1. Now, remember on the last problem, we were, and that's our answer. That's it. That's the answer. Okay, remember on the last problem, we could check our work by multiplication. So we did the number we divided by, in this case 3, times the answer, 413, remainder 1. So I'm going to say 413 plus 1 left over. Okay, so that's what that means. 413 remainder 1 means 413 plus 1 left over. So now we can do our multiplication and check it. So right now, this is not the problem. This is just checking to see if we got it right. And this is a good thing to do because, you want to make sure you got things right. So I'm going to multiply 413 times 3. And then after I'm done with that, I'm going to add 1. Okay, so 3 times 3 is 9, 3 times 1 is 3, 3 times 4 is 12. So 1,239 plus 1 is 1,240, and that's what I started out with. So that worked. So this answer is true. We checked our answer, but the real answer is 413 remainder 1. Now, let's go back and just think about what this might mean in a word problem, just real quickly. Let's start with the first one. If I have 108 candy bars and there are 9 students in the class, how many candy bars does each student get? Now, I hope you said 0 because there's no way I'm sharing my candy bars with anybody. I'm keeping them all. I get 108, nobody else gets any. But if you said 12, you could be forgiven for thinking I'm more generous than I really am. That's how division works. Right? Dividing things up evenly, everybody gets the same amount. But what about this situation? If there's 1,240 Let's just say there's 1,240 candy bars, and we're going to ship them off in cases of 3. So it takes 3 candy bars in a little package, and we ship them off. How many little boxes do we need to ship all these candy bars? Well, if we say 413, then we would have 1 candy bar left over. So if we want to ship all the candy bars, then we're going to have to get 414 boxes, because we've got to ship that last one. We can't just stuff it into one of the boxes and make it have 4 candy bars. It just won't fit, and someone might yell at us if we just slip that last candy bar in our back pocket. So it depends on the context whether you round up when you have a remainder, or you round down, or you just say, I've got a remainder, I've got some left over. So that's something for you to think about and play around with this lesson. Enjoy, and I hope to see you soon.